Hello, good day. My name is Dr. Numendem Dixon Kafu, and I'll be helping you today with solutions to some General Certificate of Education examination questions. We would be involved with both the advanced and ordinary level exam questions for mathematics. The series of such questions and solutions would be the Math Salon. The intention of this series is to help you solve model questions as well as give you some underground information around the topic concerned for the question. That means we will try to give you as much information as possible to make mathematics much more attractive and beautiful while preparing you for your examinations. Wish you good luck. So today we will start with remainder theorem. The first question you see on the board is about remainder theorem. And in the remainder theorem, there's just an idea that we have. If you consider a polynomial is a function made up of x and powers of x. So we have x, x to the 1, x to the 2, x to the 3, and so forth. So these polynomials can sometimes be divided by other polynomials that are smaller in degree than that. The degree of a polynomial is defined as the number corresponding to the highest power of that polynomial. So a polynomial of degree 3 means the x in that function with the highest power is to the power 3. So in that case, we will say that's a polynomial of degree 3. In the remainder theorem, the idea of remainder theorem is that if I get a function, f of x, and I divide that function by another function and get a remainder, then I can express it in this form. F of x will be written as x to the 2 plus x minus 6, for example, multiplied by a quotient function plus a remainder function. So in this case, in general terms, we can write something like this. Forget about this particular example. Sometimes this remainder can be just a constant, which means it's not a function, it's independent of x. If that is the case, then r is just a number. And this formula can reduce itself to, in general, saying, if f of x is divided by x minus a, then we can write it in this form. F of x is equal to x minus a multiplied by x of q, which is a function which has a power less than f of x, plus a remainder, which is a number. And if you want to know this remainder, it's simply obtained by substituting x is equal to a into the function of x, and the number you get is called a remainder. Sometimes that remainder is 0. When it is 0, we call x minus a factor of the function f of x. For the question at hand today, we have a question that says f of x is a polynomial of degree 3. When f of x is divided by x minus 2, the remainder is 4. And when divided by x plus 3, the remainder is minus 1. Find the remainder when the function f of x is divided by x squared plus x minus 6. So it's about the idea of remainder theorem. So we will check here. The f of x function is to the degree 3. We will divide it by x to the 2 plus x minus 6. That means we still have a remainder that is of the form with x, because then the power of this is only 2. We have to go up to 3. If we look at this general form coming from here, then it means f of x is equal to x to the 2 plus x minus 6 times a certain function plus a remainder. Because this is of the power 2 and this is of degree 3, it means our remainder will be of the form ax plus b. If that is the case, then we can move on to say, if f of x divided by x minus 2, we get from the equation that the remainder will be 4. That means if I substitute x is equal to 2 in the function of x, the answer should be 4. I don't know the function f, but at least I know its remainder. But we also know that the expression of f of x ends up having this remainder term, or the remainder function here. And then we can also substitute x equal to 2 in that function, and it should have the same remainder, because this is the part that represents the remainder. If that is the case, then we come up with our first equation, which says it is 2a plus b equal to 4. If we do the same thing, f of x divided this time by x plus 3 according to the equation, then we can substitute x is equal to minus 3 into the function f of x and see that the remainder is minus 1. That is already given, so we don't need to prove that. What we need to show is that the minus 1 can also be substituted into the remainder, and of course should also be equal to minus 1. This is the idea there. So minus 1 into the function of the remainder gives us that, and that's equal to minus 1 according to the equation. We have two equations that can be solved simultaneously with two unknowns a and b. One way of doing that is just elimination. So if I say, oh, just we subtract. So 1 minus 2, equation 1 minus 2 means 2a minus 3a. That gives me 5a. And b minus b disappears. And 4 minus 1 becomes 4 plus 1, and that is 5. So if 5a is equal to 5, that means a is equal to 1. I can substitute a equal to 1 into the first equation in order to solve for b. That means 2 times 1 plus b is equal to 4. That is done in this equation here. If that is the case, then b is equal to, I take this 2 to the other side, it becomes 4 minus 2, and answer is 2. I just need to replace now my a and b with the values that we've calculated, and that means I put 1 here and I put 2 there. So my remainder is x plus 2. Thank you.